All right, going to be working through the 7.1 homework here. First question I already did, but it just asked us to identify 270 degrees. And we did this in class. The main idea is that the full revolution is 360 degrees. So if we break it up into four parts, you'll have 90, 180, 270, and 360. So 270 is obviously this angle here, this positive angle that goes through quadrant 1, 2, and then 3, and then stops here at 270 degrees. Now, the next question asks us to draw the angle 675 degrees. Now, this is a little bit more involved, and that's because 675 is not a common angle. But I believe that that should be a multiple of 45 degrees. So if we just take 675 and divide that by 45 on our calculator, we'll get 15. So a way you can think about this is, if 90 degrees is this angle here, 45 would be halfway. So you go 45 degrees here, and then another 45 is 90. Another 45 would take you here, another 45 here, then another 45 there, another 45 here, another 45 would take you here, another 45 all the way back. So what we can do is start counting. And since 675, we divided that by 45, and I said that we got 15. Means if I do 15 of these jumps, that's where we'll be. So I'll do this in a different color. So we're gonna do 15, 45. So 1, 2, 3, 4, 5, 6, 7, 8, and now 9, 10, 11, 12, 13, 14, 15. Here's where we are. So looks like it can't be that one. So we went all the way around. It looks like this one. Definitely not here, definitely not here. So it's got to be B. Okay. All right. So next one, it says find 3 pi over 2 as in radians. So this again is going to require a little bit of thinking here. So we know that all the way around is 2 pi. We know that halfway around, 1/2 of a revolution is pi. And so that means that straight up is pi over 2, that's half of pi. And so the way that I like to do this, and you'll see how useful this is later, is that if 90 degrees is pi over 2, then that's 90 degrees there, then 2 of those, 2 pi over 2s would be here. So this is actually 2 pi over 2s. And you can see that the 2s would just cancel and you get pi, but I'm looking at more like we're counting. And this here, they want us to do 3 pi over 2s. So that means I'm gonna go 1 of these, 2 of these, and then 3 of these. That should put us there. So that's 3 pi over 2. So it should be this one here. All right, we'll get plenty of practice with that later. Okay, negative 11 pi over 6. All right, so for this one, same thing. This is a little tricky. So remember, this is pi, right, all the way around. So what we can do is we can imagine breaking up pi into 6 equal pieces. If we do that, we'll have, let's see here. I'll do this dotted, hold on. So I'm breaking the first quadrant into 3 equal pieces, second quadrant into 3 equal pieces. And so this first angle here is pi over 6. Then if we go another pi over 6, now we're at 2 pi over 6. If we reduce that fraction, it gives us pi over 3. And if we do a third one, we'll be at 3 pi over 6, which we know is just pi over 2 if we reduce the fraction. And then this one is 4 pi over 6, which if we reduce the fraction is 2 pi over 3. Then we have 5 pi over 6. And then finally 6 pi over 6, which is pi, which we already knew when we started this. So what I'm again trying to get you to see is how I'm using this basic angle pi over 6 to count my way around. Now, I'm gonna continue in the other quadrants into breaking those up into 3 sections. And so each time I jump from one to the other here, it's a pi over 6. We're trying to find negative 11 pi over 6. So I'm going to start here in my standard position. I'm going to start counting backwards. 1, 2, I'm going backwards, or I'm going clockwise because it's a negative angle. And I want to count 11 jumps. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11. I come up just short of all the way around. So my angle really is this angle right here, like that. Okay, so which one of those is it? It's not this one, not that one. Looks like that one, not that one. Okay, so C. Okay, 7 pi over 2. Okay, so we've already counted by pi over 2 already. This is 7 of them. So I'm going to do 7 90-degree jumps. 1, 2, 3, 4, 5, 6, 7. So here's where I am. So it's really like I went all the way around to here like that. And that looks like, let me see. Oh, actually, we went around twice. Sorry. Let me erase that. Get rid of that. So what we did is we went around one time, then we went around like that. That's what we did, which is this one here, C. So we should have C here. All right, convert degrees to radians. So all we do here is we take 300 degrees, multiply that times pi over 180. That was our conversion factor. We're trying to get rid of degrees and go to radians. So I'm going to go 300 pi over 180 degrees. And now be careful here. It says type an exact answer in terms of pi. So I'm not going to get on my calculator and do 300 times pi. I'm going to reduce this fraction, 300 divided by 180. And when I reduce that fraction, let's see, you can start reducing, maybe say like, 10 goes into here, 30 times 10 goes in here 18 times. And then let's see what goes in both those. 3, 6 goes into here 5 times. And we still have the pi, and then 6 goes into here 3 times. So we get 5 pi over 3. So let me try that. So 5, what happens if I type pi? Yeah, over 3. There we go. Okay, next question. Okay, convert the angle. They want exact answer. We want to go from degrees to radians. So again, I'm going to go negative 150. Multiply that times pi over 180. And that's negative 150 over 180. And then I'll just leave the pi out here to the side like that. Now I'll reduce this. So 10 goes into both of those. And then 3 goes into here 5 times, and 3 goes into here 6 times. So we should have negative 5 pi over 6. Let's try that. So fraction negative 5 pi over 6. All right, so another one, convert the radians to degrees this time. So I'm going to want to do negative 11 pi over 6. Now the conversion here is 180 degrees over pi. And the pi's will cancel. And then we could use our calculator here. Negative 11 times 180 is negative 1980 degrees over 6. And that actually divides in evenly, so we get negative 330 degrees. So negative 330. Okay. Next one. So we want, same thing, we want to convert 5 pi over 18. Multiply that times 180 degrees over pi. The pi's cancel. And so we get 5 times 180 over 18. Now, right now I can see that 18 goes in here 10 times. 18 goes in there once, so that kind of helps me there. And then it's just 5 times 10, that's 50 degrees. So we should just have 50 degrees here. All right, now I did this in class. This one, the converting the angle in degrees to radians. So I did that in class, and then I believe I did the next one. Yeah, I did that one in class. And then on, are you sure you want to continue? Oh, wait, maybe I never checked it. Hold on. There we go. Okay. This one we did in class. This one was done in class. That's where I told everyone to stop. But I'll go ahead and continue this. So now we're moving into arc length. So we have a formula that says that if you have a circle, or sorry, yeah, let's just take a circle. And you start at the center, standard position, and then you rotate along that circle. When you rotate along that circle to a terminal, the terminal side of the angle, then you create an arc right here. Now, if this angle here, we call it theta, and this is R, then the formula is, and this arc we call S, we know that S is equal to R times theta. And they're very important that this angle must be in radians. That's an important part there for this formula to work. So here it tells us that theta is 1/3 radian and S is 3 feet. So it says, what is R? So if we know S equals R theta, and they're telling you that S is 3, and the angle is 1/3, then to figure out what R is, we just multiply both sides by 3 to clear out this 1/3 on the right side. So the 1/3 and 3 go away, you have R by itself, and now that's just 9. And so this is the radius of the circle. It should be 9 feet. And that's it. Okay, now on this one, it says find the central angle theta, which subtends an arc length 4 inches of a circle radius 24 inches. Okay, so we have a circle. Okay, and then it tells us that, oh, I don't need that. It tells us that the radius of this circle is 24 inches. And there's an arc, so there's a little angle here, theta, and they tell us that this arc length, this distance over here, is 4 inches. And so using S equals R theta, we know the S is the arc length, that's 4. That must be equal to radius 24 times theta. And they want to know what theta is in radians, so we just divide 4 over 24 is theta. So that's 1/6 is theta. So let's see, they want to type an integer, which 1/6 is not an integer, it's a fraction or a decimal. And so we're just going to do 1 divided by 6 on our calculator, and then we'll get 0.1666 repeated is theta. And so we went around 3 decimal places. So we should get 0.16, we went 3 decimal places of 7. Check that. And that's it. All right, next one. Okay, so this has to do with the area. Okay, so we have a formula now. I haven't presented that. Trying to think of how Windows. Oh. Give me a moment here. Let me pause this so I can. Okay, now I wanted to show you the formula that we got in class, the area of a sector. So if you have, we already know how to figure out the arc length, this distance on the outside, but if we want the area of this thing, that sector, like a pizza slice, then it's 1/2 the radius squared times the angle. And again, that has to be in radians. So that's what we're going to use for this problem here, is that the area will be 1/2 R squared times the angle theta. And so here they give us, tell us to find the angle which forms a sector area of 30 square inches. So this side is 30, the area, and it has a radius of 4. So we just plug in 4 for radius squared and then times theta. So 30 equals half of 16 when we square the 4. And that means 30 equals half of 16 is 8 there, times theta, and divide by 8. And then reduce this. So 2 goes in, 15 over 4 is theta. And they want this to round 3 decimal places. So 15, divide that by 4, and we get, 3.75 is theta, radians. So 3.75. There we go. All right, next one. To find the length S and the area A. So they give us the radius, here's 12, and they give us the angle here, 70 degrees. Be careful. We have to convert that to radians. We have to multiply by pi and divide by 180. And so I'll do this, let me see, let me reduce. This goes in, so 10 goes in there 7 times, 10 goes in there 18 times. So I have 7 pi, the degrees cancel over 18. And we're gonna need to get that as a decimal. So I'm gonna do 7 times pi on my calculator, divide that by 18. And I get about, let's see, 1.22173 radians. Okay, so that's the actual angle. So to find the length of the arc, I'm going to use this formula. And therefore, since the radius is 12 and the radians measure of the angle is this, I just multiply 12 times that, 1.22173. It's approximately 14.660, actually 1 if I round. So they want this 3 decimal places. So let's try that. Let's try 14.661. Okay, that's good. And now next question is that they want the area. So the area is just a different formula. So area is half of the radius, which we know is squared, times the angle, which we know is 1.22173. And so the area is 1/2, which is 0.5. Let me do it this way. 1/2 times 144 is 12 squared times 1.22173. I'll just do all that on my calculator. All right, I'm getting about 87.96. So I'll have to round that to 5 if I'm going 3 decimal places. So that should be it here. 87.965. All right. All right, 18. Okay, so all right, this one's a little confusing. City A is due north of City B. So we're imagining that we have the Earth. So there's the Earth. Here's the center of the Earth. We're assuming that the Earth is a perfect sphere. It's saying that City A is, here's City A, is north of City B. So along the curvature of the Earth, we're saying that that's directly, I said City C, City B. So there's City B. So along the curvature of the Earth, A is due north of B. And it says that City A has a north latitude. So basically what they're saying is the angle here is 45 degrees 2 minutes. And then they're saying this angle here relative to the equator, okay, is 19 degrees 50 minutes. So they want to know the distance between them. So if you look at this from the side, here's what we have. Here's the Earth, here's the North Pole, here's the equator, here's the curvature of the Earth. We have City A here, we have City B here. We know that this angle from here to here is 19 degrees 50 minutes. And here, this angle here is 45 degrees 2 minutes. So in order to find the distance between these two cities, we need to find the distance from here to here along that curve. and that we can call S, and we know that S is equal to R theta. We need the radius of the Earth, which they give us, so we know that S is equal to 3960. Now we just need theta, and everything here is going to be measured in miles. I think I forgot to tell you in the last problem that our answer here was square yards for area and length was yards. Sorry, I forgot to mention that. Here our answer is going to be a distance and measuring in miles, so our answer should be in miles. We still need to figure out what theta is. So the way that I think I'm going to go about this is I'm going to first, I'm going to try and find that angle here. So I'm trying to find this angle right there. So what I need to do is take this angle and subtract this angle. So first thing I'm going to do is I'm going to take 45 degrees in 2 minutes. I'm going to write it like that. And then I'm going to convert minutes to degrees by taking that and multiplying it by that conversion factor that I know that I'm trying to go to degrees. I know that 1 degree is 60 minutes. So the minutes cancel. I just get 2 over 60, which is the same as 1 over 30. I do that on my calculator, and I get this 45 plus the decimal I just got on my calculator, 0.0333 repeats. That's the degree measure of city A. Now city B I need to find. I'll do that right here. It's 19 degrees plus 50 minutes. Again, I'm going to take the 50 minutes, multiply by 1 degree over 50, I'm sorry, over 60 minutes, 60. And so I do 50 divided by 60, and that gives me 0.833333. Okay, so this really becomes city B is at 19.8333 repeated. And now I subtract. I need the angle here between those two. So I take 45.0333333 forever, and I subtract 19.833333. And I get approximately that angle here should be about 25.2000 degrees. Now, we're almost there, but we need to convert to radians because remember, if we're going to use this formula, this has to be radians. So I'm going to take that answer, which is in degrees. I'm going to divide it by 180, multiply it by pi, and the degrees will cancel. So I'm going to take that answer, 25, I'm just going to say 25.2, I'm going to multiply that times pi, and then I'm going to divide by 180. And so I get approximately in radians that this measurement is 0.43982. Let's just go with that. So now coming back over here, arc length is 3960 times 0.43982 times 3960 is about 1741 point, what do they want? Nearest mile. Okay, so 0.69. So I'm going to round that up to 1742. 1,742 miles is the distance. All right. Next one. Okay. The mean distance of the moon. Oh, sorry. The mean distance of a moon from a planet is this distance, right? So that's really 271. Sorry, 2.71, but we moved the decimal point 5 places to the right. So 1, 2, 3, 4, 5. Put zeros there. So this is really 271,000 miles. So they're saying that the mean distance, which is like the average distance of a moon from some planet, is 271,000 miles. Okay, assuming that the orbit of the moon around the planet is circular. So we have a planet here and we have a moon, right? We know that that distance from here to here is that number, 271,000 miles. It says, assuming that the orbit of the moon around the planet is circular and that one revolution takes 23.7 days, that's 1 day is 18 hours. So find the linear speed of the moon, express your answer in miles per hour. So this is a little confusing because it says one revolution takes 23.7 days. They say 1 day is 18 hours. And okay, so that's really what we want to say, see here is that as this thing goes around the planet, right? Like that takes 23.7 days to happen. Okay, but they tell us that 1 day is 18 hours. So what I'm going to do is I'm going to get rid of this. I'm going to multiply that 23.7 times 18. And that means it really takes 426.6 hours for it to go all the way around. All right, for it to go all the way around the planet. So this is our moon. This is our planet. Okay, the distance we know how long it takes, right, to go around one time. It says find the linear speed of the moon. So I think I'm going to go back to bring up just again the formulas that we had. Will be the next section here. Okay, so the linear speed, move that up here. So if an object moves on a circle of radius r, so we have an object moving along a circle, we know the radius. If s is the distance traveled in a certain amount of time, then the linear speed is just the distance divided by the time. Okay, now the problem that we have here is that we don't know the distance it traveled. Okay, we need to figure out the distance that it traveled to go all the way around. So this is where we need to think through this. So to find the linear speed, sorry, I'm sounding, the linear speed v is going to be s over t. Okay, time we know it takes 426.6 hours. We know how long it takes to go all the way around. We just need to know the distance it travels. So we need to measure the arc length, which is basically this all the way around. That's our s. But we know s is equal to r times theta. So s should be the radius times theta. But if we go all the way around, then the angle theta is 2 pi because that's an entire revolution. And remember, this has to be in radians, so that's why I'm using pi, not 360. So my total S should just be, I'm doing my calculator, 271,000 times 2 times pi, which is approximately 170,2743.218. That should be miles. Okay, so that's how far it traveled. That's really the circumference of the circle. And so that goes here, 170,2743.218. I take that and divide it by 426.6. And that gives me, this was miles, and we're dividing by hours, so our answer should be miles per hour. So 3991.428. I'm just put mph, miles per hour. So let's try this. So this is 3991.428. Uh-oh. What's going on here? Round to the nearest integer. Sorry, I went 3 decimal places. So it's just going to be round down. So there we go. All right, good. Hope that makes sense. That completes the assignment. So that's it for the video.